Yeah. Good evening, everyone. Good evening. Yeah. Please, Anjali, please verify my voice is okay or not. Anjali, please verify my voice okay or not. Is it audible or not? Yeah. Fine. Yeah. Now start now. Yesterday we discussed about recursion, right? As you know, yesterday we discussed about recursion. Recursion means first one, a function calling itself is a recursion. I think 8 points you are also written. Right? I still remember you all written you written everything. Right? First point is a function calling itself is known as recursion. Second point is solving bigger problem in terms of smaller problems is known as recursion. And third point is right. Third point is right. Whatever it may be the order, I will say random order. Right? Don't worry, I will say random order. Those people who are not attended yesterday's class, you can go back and you can check once. Right? If you already attended, let me remind you one time. Right? I will say in random order. So all the points I will say once. A function calling itself is known as recursion. That is the one point. Solving the bigger problem in terms of smaller problems. That is also recursion. One more. Next one. Every recursive program should have termination condition. Otherwise, we will get stack overflow error message. It don't go to infinite loop. It want to go, but unfortunately, in between stack is over, so it will give stack overflow error message. And the stack overflow error message, it is not a compile time error. It is a runtime error. The reason is compile time program will not run. Compile time, right? Just only right, checking will be done. Program is syntactically, semantically correct or not. But running time only running is going on. So running time, unfortunately, stack space is over. It will give the error message stack overflow. Next one, every recursive program should have termination condition. We are already done. Next one, when the recursion is going on, one function call to another function call, right? Function name will not change. Number of parameter will not change. Name of the parameter will not change. Only value will change. That is the one more thing. And one more thing is going to be to execute the recursive program, we are using stack data structure. And one more thing is for every recursion, non-recursion possible. For every non-recursion also, recursion is possible. Next one, comparing recursive program, non-recursive program. Recursive program will take most of the time, more stack space because of more function calls. Non-recursion, very less function call, most probably constant, right? But in the recursive program, stack space is right huge. Most of the time, recursive program will take more stack space comparing with the non-recursive program. Right? Fine. These are the points which we discussed. If any point is left out, let me know. If any point is left out, let me know. The next one, while recursion is going on, the number of stack units you are using, that is called depth of the stack. While recursion is going on, the number of stack units you are using, that is called depth of the stack. Right? Depth of the stack. Okay, these are the things which we see. Right? Let's see the remaining part. Everyone listen. Let's see the remaining part. So yesterday if you observe factorial recursive program I written, see this one. Yesterday if you see factorial recursive program, factorial of n recursive program I am saying, if n is less than or equal to 1, return 1, else return n into fact of n minus 1. So this is the factorial recursive program. If n is less than or equal to 1, return 1, else return n into fact of n minus 1. N into fact of n minus 1. It is a recursive program. Right? It is a recursive program for factorial. Now listen. Listen everyone. One important thing is coming. Everyone have to listen. Everyone, whoever listening, be careful. Right? It is a recursive program. Factorial recursive program. Right? So how this is running, yesterday I explained to you. Right? So now I am saying some other story. Can you listen one time? Careful everyone. Let us assume. Let us assume. Let us assume. Let's assume. Careful everyone. Everyone see this one. Let's assume T of n. Let's assume V of n. V of n. V of n is, let's assume V of n. V of n is the output of the, let's assume V of n is the output of fact of n. Let's assume V of n is the output of the fact of n. Right? Careful this line. This line is very important. Let's assume V of n is the output of the factorial of n. Can you help me now? Those people who are watching this, please give the answer to me. Let's assume fact of n output is V of n. Let's assume fact of n output is V of n. If you believe this statement is right, can you help me now? Fact of n output is V of n. Fact of n minus 1, what will be the output? I want answer. Fact of n output is V of n. Fact of n minus 1, what will be the output? Right, those people who are watching, please let me know. Fact n output V of n. Fact n minus 1, what is the output? Can anyone guess? Fact n output is V of n. Fact n minus 1, what will be the output? Those people who are watching, please respond. Otherwise, class is so boring. You are watching and you are not responding. Some people will come one day, some people come another day. Coming one day, coming another day. One day you don't come, one day you will come. If you come also, you don't respond. Right? Fact of n value is, if at all, V of n. Fact of n minus 1 value is V of n minus 1 exactly. Right? Fact of n value is V of n. If you assume fact of n minus 1 value is V of n minus 1. Everyone know this? Everyone knows. So, right, I think I'm thinking that you are absolutely correct. Right? Anjali, you are absolutely correct. Now see what I'm doing. You are absolutely correct. See what I'm doing. Everyone have to listen. See this. Fact of n, if output is V of n. Fact of n, if output is V of n. Can you help me now? Fact of n minus 1. What is the output? V of n minus 1. Fact of n output is V of n. If you believe that is true, fact of n minus 1 output is V of n minus 1. Right? And one more thing. See this one. If n is less than or equal to 1, return 1. So output is 1. If n value less than or equal to 1, output is 1. This is direct. See, fact n output V of n. Fact of n minus 1, V of n minus 1. That is okay. Recursion, see. Recursion. See this one. If at all fact of n is V of n, fact of n minus 1, V of n minus 1, it's okay. Remaining things you see. N less than or equal to 1, output is 1. Right? If at all this condition is failed, then output is going to be n into V of n minus 1. So let me write now. Then see this one. Then careful. Let's assume V of n is the output of fact of n. Then careful. Then recurrence relation. This is called recurrence relation. See this one. Then recurrence relation V of n is equal to. Then recurrence relation V of n is equal to. Careful. then recurrence relation V of n is equal to, can you help me now? Can you help me now? Fact of n output is V of n, right? If that is the case, go inside. N value less than or equal to 1, return 1. N value less than or equal to 1, return. What is the answer? V of n output is 1 if n is less than or equal to 1. V of n means output of the above program, right? Is answer is 1 if n is less than or equal to 1. Suppose using that if condition is fail, then output is going to be n into V of n minus 1. If n is less than or equal to 1, output is 1. Otherwise, n into V of n minus 1. Right? Otherwise, n into V of n minus 1 if n is greater than 1. This is the recurrence relation. V of n means output. Output of the above program is 1 if n is less than or equal to 1. Output of the above program is n into Vn minus 1. If n is greater than 1, means same thing. Whatever over I written same. Fact of n output is V of n. Fact of n output is V of n. If you believe, fact of n minus 1, V of n minus 1. Right? Now, if you go inside, n less than or equal to 1, return 1. So, output of the, if n less than or equal to 1 is return 1. Otherwise, n into V of n minus 1. See, same program, whatever way it is there, same way I written. The only thing is I written V. V means value. V means value. Value means output. Let's assume V of n is the output of the fact of n. Then V of n is equal to 1 if n is less than or equal to 1. Otherwise, n into V of n minus 1 if n is greater than 1. Let's assume V of n is the output of the fact of n. Then V of n is equal to 1 if n is less than or equal to 1. Otherwise, n into V of n minus 1 if n is greater than 1. Is there anyone who is having doubt here? Hello sir, how are you? I am fine. I am fine. Those people who are not getting, please let me know. Sir, this is my problem. If anyone says, sir, I am not getting, what you are not getting, can you post in the comment section? Those people who are having doubt, can you type in the comment section? Yeah, fine. Now listen, those people who are saying that you are okay, listen. If you are saying that you are okay, if you are thinking that you are okay, one small thing I want to ask you. For every recursive program, everyone listen. For every recursive program, recurrence relation possible. This is called recurrence relation. For every recursive program, there is a recurrence relation. Same recursive program, right, in the form of a relation. That is called recurrence relation. Fact of n value is V of n. Fact of n, if value is V of n, then V of n is equal to 1 if n is less than or equal to 1. Otherwise, n into V of n minus 1. For every recursive program, recurrence relation possible. Write the same thing in the form of a mathematical relation, which is known as recurrence relation. Write the same recursive program in the form of a relation, which is known as recurrence relation. I think you are okay. Now listen. I think you are okay. Careful everyone. Can you see this also? If you are careful, can you see this also? Let us assume. Or let's assume. Everyone have to understand. Let's assume T of n is the time complexity of, let's assume T of n is the time complexity of above program. Let's assume T of n is the time complexity of fact of n. Let's assume T of n is the time complexity of fact of n. Let's assume T of n is the time complexity of fact of n. Is it buffering? Yeah. Let's assume T of n is the time complexity of fact of n. If anyone says, sir, I am okay. Remember it's the time complexity. Let's assume T of n is the time complexity of fact of n. Is it buffering? Is it buffering? No. Is it buffering? Is it buffering? Please let me know if it is buffering. Yeah, now see that. If it is not buffering, now see. See this. See this one. Let's assume T of n is the time complexity of fact of n. Let's assume T of n is the time complexity of fact of n. Now listen, because of everyone is fine. Let's assume T of n is the time complexity of fact of n. Can you see this? Very interesting line. Very interesting thing. I am writing with a different color. I am writing with the black color. See this one. I am writing black color. See this one. Fact of n. Everyone listen. Fact of n time complexity is T of n. Fact of n time complexity T of n. If that is the case, fact of n minus 1 time complexity Tn minus 1. Right. Now see this. Fact of n time complexity T of n, if you assume fact of n minus 1 time complexity Tn minus 1. Now can anyone help me? If n less than or equal to 1, return 1. If n less than or equal to 1, return 1. What is the time complexity? If n less than or equal to 1, return n. Return 1. I think see, no loop, nothing. Careful. No loop, nothing. Time complexity is constant. When you say time complexity, loop. If n less than or equal to 1, return 1. No loop, constant. But I am repeating once again. Time complexity means loop. If n less than or equal to 1, return 1. Where is the loop? Constant. Next one. But one thing remember, fact n time complexity Tn. Fact n minus 1 time complexity Tn minus 1. Time complexity means loops only. In the if condition, if n less than or equal to 1, return 1, no loop. So time complexity constant. But if you see the return, listen, n into fact n minus 1 is Tn minus 1, okay. But one thing I want to ask you, it is the recursion, keep as it is, n into Tn minus 1. But one small question I want to ask you, n into Tn minus 1. So you cannot write n because there is no loop. If loop is repeating n time, then I can write n. There is no loop here. Simply multiplication, which will take constant. Time complexity means loops. See, in the if condition also no loop, constant. In the else condition also no loop, constant. But recursion is recursion. Recursion always takes same. What is the meaning of recursion always takes same? Fact of n value v of n. Fact of n minus 1 value bn minus 1.
fact of n time complexity Tn, fact of n minus 1 time complexity Tn minus 1. Recursion is always same. Recursion always same, that's okay. But when you say time complexity, wherever you go, you have to think about loop. In the if condition, no loop. No for loop, no while loop, constant. In the else part, no loop, constant. But recursion is recursion. Some people are asking, sir, why constants are? You are multiplying, see, you are multiplying n and Tn minus 1. You are multiplying, which will take constant. Now see the answer. Now see the answer. Let's assume T of n is the time complexity of fact of n, right? Then, see this one, then recurrence relation, see the recurrence relation. T of n is equal to, then recurrence relation T of n is equal to, see the answer. T of n means time of fact n. Then T of n is equal to constant time if n is less than or equal to 1. T of n is equal to constant time if n is less than or equal to 1. If this condition is fail, listen, if this condition is fail, in the else part also no loop is there. But recursion is there but no loop. Then what is the answer? Because of recursion Tn minus 1. Because of no loop, nothing, right? Constant. Constant. No loop is there. In the else part, there is a recursion. Recursion is recursion. Fact n, Tn, fact n minus 1, Tn minus 1, it's okay. But in the else part, if you observe, no loop, nothing. Simply one multiplication. Constant time. If n is greater than, right? If n is greater than 1. Remember, this is the recurrence relation for, right? Time complexity. This is the recurrence relation for output. Right? For the given recursive program, output purpose it is the recurrence relation. For the given recursive program, time complexity purpose it is the recurrence relation. Can you see one more? Can you see one more? Can you see this one? Let's assume. Careful everyone. Let's assume m of n is, let's assume m of n is number of multiplications. Let's assume m of n is number of multiplications needed. Let's assume m of n is number of multiplications needed in fact of n. Let's assume m of n is number of multiplications needed in fact of n. Let's assume m of n is number of multiplications needed in fact of n. Right, that is the thing. You only say in this program, see, recursion is recursion always. Recursion, I cannot do anything. Other things only will change. Some people are thinking that, sir, why recursion is not changing? Recursion is recursion. Fact n, Vn, fact n minus 1, Vn minus 1. Fact n, Tn, fact n minus 1, Tn minus 1. Recursion is recursion. Other things will change. Be careful with other things. Right? Now see this one. I think m of n means multiplications. M of n means multiplications. Let me use another color. I will try another color. Let's check here. Yeah, fine. I'm going here. See this one. See everyone listen. Fact of n multiplications are m of n. Fact of n multiplications are m of n. Can you help me now? Fact of n minus 1, m of n minus 1. Recursion is recursion. Fact of n multiplications m of n. Fact of n minus 1 multiplications are m of n minus 1. Right? Fine. That is fine. That's fine. But some people are asking, sir, can you come inside? Recursion is always okay. Can you go inside? Can you check? Let's see this one. Fact of n multiplications m of n. Fact of n minus 1 m of n minus 1. It's okay. But can you go inside? If n is less than or equal to 1, return 1. You only say, if n less than or equal to 1, return 1. Any multiplication in this line? No. So number of multiplications 0. In the if condition, nowhere multiplication operator star. Right? In the if condition, nowhere multiplication operator is there. So number of multiplications if condition 0. Recursion, I cannot do any change. Fact n multiplications mn. fact n minus 1 multiplications m of n minus 1. Recursion, I cannot do anything. As it is, you write in the recursion. But in the remaining parts, if you observe, if n less than or equal to 1, return 1. In that line, where is the multiplication? No multiplication, write 0. Number of multiplications in the if 0. But if you go to the else part, in the else part, see this one multiplication there. In the else part, one multiplication there. Recursion is recursion, okay. In the else part, one multiplication, the number of multiplications in the else part is 1. Recursion, I cannot change. Recursion, I cannot change. Other things you should be careful. In the else part, number of multiplications are 1. Right? 1 including recursion. Recursion is there. Recursion is there. And in the if, no multiplication at all, 0. In the else, 1 multiplication, right? 1. Because of your little okay, right? See this. Because of your little okay, see this one. Number of multiplications of fact 10 mn is equal to number of multiplications for fact 10 is mn is equal to 0 multiplication if n is less than or equal to 1. 0 multiplications if n is less than or equal to 1. Next one. See everyone now. M of n minus 1 plus 1 multiplication if n is greater than 1. Check. M of n, number of multiplications for fact of n is m of n. M of n is 0 if n is less than or equal to 1. M of n is m of n minus 1 plus 1 if n is greater than 1. Some people are asking, in the else part, why 1 came, sir? In the else part, 1 multiplication there. So 1 came. Sir, in the else part, why m of n minus 1 came? Recursion there. Fact 10 mn, fact n minus 1, mn minus 1. Can anyone help me now? Until now, I written the recurrence relation 3 times. Until now, I written the recurrence relation 3 times. What are those? Please, can you write? Please write. Those people who are watching, can you help me? Until now, for the given recursive program, I written 3 recurrence relations. Until now, for the given recursive program, I written 3 recurrence relations. Can you guess what purpose? Can you guess what purpose? Can you guess what purpose I written the recurrence relation? Please help me. Until now I written for the given factorial program 3 recurrence relations. Until now I written for the given factorial recursive program 3 recurrence relations. What purpose I written? Can anyone help me? Sir, you written the recurrence relation for this purpose. You written the recurrence relation for that purpose. You say to me, I will help you. What purpose you written? Check. What the answer? 1 for output, 1 for time, 1 for multiplication. Exactly. Right? 1 for multiplication, 1 for output, 1 for time complexity. First one for output, second one for time complexity, third one for multiplication. I think by seeing this one, people realized one thing. What the answer? For every recursive program, recurrence relation possible. For every recursive program, recurrence relation possible. But many recurrence relations possible. For every recursive program, recurrence relation possible. But many possible. Not 1, not 2, not 3. Not 1, not 2, not 3. Many. I may be written 3. I written for output, I written for multiplication, I written for, right? What is one more thing? First time complex, first is I think output, second is time complexity, third is multiplication. Right? If you ask me, sir, can you write the recurrence relation for addition? Fact of n additions are a of n. Fact of n minus 1 additions are, what is the answer? A of n minus 1. So additions also I can write. Subtractions also I can write. I can write whatever I want. I written first output, I written second for time complexity. I written third for multiplication. If I want, I will write for addition. If I want, I will write for subtraction. If I want, I will write whatever purpose I want. If I want, I will write the recurrence relation for factorial of n, right, to do Bharatanatyam also. If anyone asks me, right, for the given recursive program factorial, can you write the recurrence relation for Bharatanatyam? I can do that. If really needed, I will do. What I want to say indirectly directly is, for the given recursive program, recurrence relations many possible. How many? As you wish. Sir, what purpose I can write? Right? Time complexity purpose I can write. Output purpose I can write. Multiplications purpose I can write. I can write for anything. Whichever I want, I will do. This is the meaning of analysis. Right? Some people, what they will do is, they will give recursive program, they will ask you, in the above recursive program, I want to do this. What is the procedure? Whatever way I done, please follow it. I done for multiplication, can't you do for addition? I done for multiplication, can't you do for subtraction? It is possible. The only thing is, what is your requirement? You should have clarity. Accordingly, you have to plan it. Check anyone having any doubt. Right. So those people who are saying that, sir, I got everything whatever you said. Can you do yourself one thing? Those people who are watching, can you type? In the comment section? Let us assume. Listen. Let's assume. Everyone. Let's assume fact of n. Number of additions are a of n. Can you write the recurrence relation? Fact of n. Number of additions are a of n. Can you write the recurrence relation for that? Can you type in the comment section? Fact of n. Number of additions are a of n. Fact of n. Number of additions are a of n. For a of n, can you write the recurrence relation? Can you try once? Please check those people who are watching. Can you write this? I written 3. Can you write the fourth one? Fact of n, number of additions are a of n. Right? Can you write for a of n? Right? A of n purpose, can you write the recurrence relation? I written for 3. Can you try once? I written for 3. Can you write once? Those people who are watching, can you type? Even though right or wrong doesn't matter. Even though wrong, no problem. Can you type once? Even though wrong, no problem. Can you type once? Same. See, 3 things I done. See, whatever model I followed, please follow same way. Don't write whatever way you want. See, this is the first two. Let's assume V of n is the output of the fact of n. Then recurrence relation is like this. Let's assume T of n is the time complexity of fact of n. Then T of n is equal to this. Let's assume M of n is the number of multiplications needed in fact of n. Then M of n is this. Whatever way I written, you should also write similar. Don't write your own way. Usual, don't write whatever way you like. Whatever way I written, I want in the similar fashion. Please, can you write once? Please. So I given enough time. Some people are written. Let me write it. Let me write interesting answer. Let me write here. Let me write this. Let's assume A of n is number of additions needed to fact of n. Let's assume A of n is number of additions needed to fact of n. Then see this one. Then recurrence relation A of n is equal to answer is what the answer? Can you go here? This is the tricky. That is the reason people used to say computer science means common sense. That is the reason people used to say computer science means common sense. This is the only reason. You have to use common sense. There is no by-hearted things. Right? You have to use common sense. Otherwise, it is going to be very difficult. You have to use common sense. Recursion is recursion. Recursion always same. Right? I will try. How much you understood, I will try now. Just let me remove unnecessary things. Otherwise, it will confuse you. Yeah. See this program? Everyone listen. See this program. In this program, careful. In this program, if you observe clearly, see this one. Fact of n number of additions are A of n. Fact of n number of additions are A of n. Fact of n minus 1 number of additions are A n minus 1. Same. Fact of n number of additions are A of n. Fact of n minus 1 number of additions are A of n minus 1. That is okay. Recursion always same. Names only will differ, but it is always same. That's okay. But your concentration is addition. Your concentration addition. Can you help me now? In the if condition, at anywhere are you seen? Right? Press operator. Right? If you see the if condition, in the if condition, at anywhere are you seen? Plus operator. No. So the number of additions in this line 0. The number of additions in this line is 0. Right? Now can you go to the else part? In the else part, if you observe, recursion okay, I don't have any problem. Listen, recursion okay, I don't have any problem. But if you observe clearly in the else part, at anywhere plus there, no. So 0. In the else part, at anywhere using plus operator, no, 0. In the else part, at anywhere using multiplication operator, yes, one time is there. So 1, that is for multiplication. Multiplication is there one time. So 1, that is for multiplication. Recursion always same, you don't need to do anything. Additions not there, 0. Multiplications there, 1. Next one, subtraction, 0. Division, 0. If they are right, otherwise you don't write. Recursion, I cannot do anything. Remember, recursion, I cannot do anything. So, number of additions in the fact of n is 0 if n is less than or equal to 1. Otherwise, recursion, a n minus 1, that's fine. Right? So, next one, how many multiplication? 0 multiplication. 0 multiplications. In the else part, no multiplication. So, 0 multiplication. If n is greater than 1. If n is greater than 1, be careful. Be careful. Can you help me now? Listen everyone. Listen everyone. Can you see the one interesting thing? Can you see the one interesting thing? Everyone listen. Can you see one interesting thing? See this one. Can you see one interesting thing? For the given recursive program, listen. For the given recursive program, if you write the recurrence relation for output, for the given recursive program, if you write the recurrence relation for output, the advantage about this one is, see this one. For the given recursive program, if you write the recurrence relation for output purpose, as it is you can copy. See this one. Here n into, here also n into. N into, see this one. If you want, you can check. For the given recursive program, if you write the recurrence relation for output is same. Same you have to write. When you say output, whatever is there in the else part, same thing you write. Don't change also. Fact of n is v of n. Fact of n minus 1 is v of n minus 1. Okay. Remaining all as it is you write. Here multiplication is there. Here also write multiplication. Here n is there. Here also write n. Everything if you copy, that is the recurrence relation for output. Recurrence relation for output writing easy because as it is copied. But recurrence relation for other things, you have to use a little common sense. For other things, you have to use common sense. If you observe clearly, for other things, can you see the other things? Multiplication. How many multiplications are there? 1. There is no multiplication. There is no, see, while writing, you no need to write star, nothing there. How many multiplications here? 1. How many additions here? 0. You cannot write as it is. 1 multiplication there. So 1. 0 additions are there. Plus 0. Recursion is recursion. Next one. Here no loop is there. Time complexity constant. Only recurrence relation for output is as it is. Recurrence relation for output is as it is. Other things you have to write properly. You have to write properly. Because of you are really comfortable. Right? Lastly, one question I am asking. Those people who are watching here, I want to ask you one thing. For the given recursive program, how many recurrence relations possible? Can you type? For the given recursive program, how many recurrence relations possible? Can you type? This is the final conclusion. For the given recursive program, how many recurrence relations possible? Can you type? Those people who are watching, please comment in the comment section. For the given recursive program, how many recurrence relations are possible? That's the first question. How many? Many. So how many I return? Many possible. Thank you so much. But how many I return? Many possible. Depending upon our requirement, we can write any number. How many I return? As of now, how many I return? 4. Can you help me now? Out of those 4, anything is not clear. And can you help me now? Out of those four, which one is as it is? Out of those 4, which one as it is like program? Out of those 4, which one is as it is like program? Out of those four, which one is as it is like program, as it is copy? Output. Output is as it is. Remaining thing. When you say time complexity, you have to think about loop. When you say time complexity, go to the if part. Time complexity purpose. Go to if part. Any loop? No. Constant. Go to the else part. Any loop? No. Constant. Right? Next one. Additions. Go to the if. Any place operator? 0. Not there. 0. In the else part. Any place operator? No. 0. Multiplication. Go to the if part. Any star operator? No. 0. In the else part. Any star operator? Yes. One time. 1. Very simple. Right? Because of you are really okay. Can you do one practice from your side? Can you do one practice from your side? Take the one problem. Take one problem once. Take one problem. I'm expecting answer. I don't know how many people will give. Let's see. See this one. Fibonacci of n. Listen. Fibonacci of n. If n is equal to, see this one. N is equal to 0 or n is equal to 1. N is equal to 0 or n is equal to 1. Return n. Fibonacci. Simply I am writing Fibonacci program. If n is equal to 0 or n is equal to 1, return n. Else return Fibonacci of n minus 1 plus Fibonacci of n minus 2. This is the recursive program. For Fibonacci series, it is a recursive program. I want answer from you. Now listen. Write recurrence relation. Write the recurrence relation for output time complexity additions. Write recurrence relation for output time complexity additions calculation. For additions, write recurrence relation to find. Okay, let me change the line. Write the recurrence relation to find output time complexity additions in the above Fibonacci of n. Write recurrence relation to find output time complexity additions in the above Fibonacci of n program. I want answer. Can you try now? This one, if you can handle, you are perfect. Write recurrence relation to find output time complexity addition in the above Fibonacci of n program. Yeah, this is the program. In this program, for additions purpose, write the recurrence relation. For output purpose, write the recurrence relation. For time complexity purpose, write the recurrence relation. Can you try one time? It's the right answer, wrong answer, doesn't matter. Can you check once? If you can do this, today, what purpose you attended this class? Almost you fulfilled it. I want 3. Output also, time complexity also, additions also. If possible, can you write for multiplications also? If possible, can you write for multiplications also? If possible, can you write for multiplications also? 4 I said, can you 3 I said, can you write for 4? Multiplications also I want. I want answer for multiplications also. I want answer for multiplications also. Can you try once? Yeah, I given enough time, so I will try to give answer. Please check if you can understand what I am talking. You will easily get right all the things. Let's check. See the answers one by one. See the answers one by one. See the answers. Output purpose, recurrence relation. Output purpose recurrence relation. Write as it is. Output purpose recurrence relation. Write as it is. What is the answer? Output means value. V of n is equal to. See this one. V of n is equal to as it is. Right. See the as it is. What is the meaning of as it is? See this one. As it is. N value 0 or n value 1. Return n. Listen. Return n. You are returning. As it is. As it is you write. What is the answer? V of n is equal to n. Return n. N. Return n if n is equal to 0 or n is equal to 1. Otherwise, can you go to else part? Can you go to else part? What is the answer? See this one. If this is V of n, this is V of n minus 1, this is V of n minus 2, we cannot do any change in this. If Fibonacci of n is Vn, Fibonacci of n minus 1 is V of n minus 1, Fibonacci of n minus 2 is V of n minus 2. In that no doubt, can you help me now? Can you help me now? Because of it is the output. Write as it is. What is the meaning? Plus there plus. Minus there minus. As it is you write. So answer become, listen, answer become else part Vn minus 1 plus Vn minus 2. Right? If n is greater than 1. Else means n is greater than 1. N 0 or 1. Then if condition. If n is more than 1 is the answer. How many people return correct? How many people return correct for output? Let's check. How many people return correct for output? Output is as it is. Yeah, Mayank, my suggestion is right, do half time, right? Do 80% time, do 80% time, 70% time for practice, 30% time. Those two subjects you can study. 70% time practice, 30% time those two subjects. You can handle. Mayank, don't leave it. Mayank, don't leave. 70% practice. 30%, right? You can study those two subjects. 15% is one subject, 15% is one subject. Like that plan. Don't leave any subject. So this is for output. Can you see the next one? Output I done, it's okay. See the time complexity. Time complexity recurrence relation. Time complexity recurrence relation. See this one. Time complexity Tn is equal to, everyone listen. Time complexity means think about loops. Okay. Time complexity means loops. Time complexity means loops. Can you see this one? Time complexity means loop. Listen everyone now. Because of time complexity, Fibonacci of n is T of n. Fibonacci of n minus 1 is Tn minus 1. See, recursion is always same. Recursion is always same. No change. Time complexity means loops. Recursion is recursion. Fibonacci of n, T of n. Fibonacci of n minus 1, Tn minus 1. Fibonacci of n minus 2, Tn minus 2. That's okay. That's okay. But when you say time complexity loops, can you help me now? Any loop here? In the else part, any loop? No. So you have to write plus C. No loop means constant time. In the if condition, anywhere loop? No. Constant. If you want, you can write here also C. Constant means order of 1. Constant means order of 1. I think over. Let me write now. T of n is equal to constant time if n is 0 or 1. If n is 0 or 1. T of n is equal to C if n is 0 or 1. Otherwise, listen. Otherwise, Tn minus 1 plus Tn minus 2 plus C if n greater than 1. This is the recurrence relation for time complexity. This is the recurrence relation for time complexity. Hi Shobit. Hi Shobit, how are you? Hi Shobit, how are you? Nice to see you. Yeah, this is for time complexity. How many people written time complexity answer correctly? How many people are written time complexity answer correctly? Let me see Anjali how what she written. Let's see Anjali what she written. Output she written fine. Yeah, fine. So what is the time complexity? Let's check. Tn minus 1, Tn minus 2 plus C. Anjali plus C. Plus C. You cannot say no time complexity. Anjali, you cannot say no time complexity. Plus C. Anjali, you cannot say time in the else part time complexity. Nothing you cannot say. Whenever, no loop, right? Plus C. Yeah, whenever, see this one. Wherever you go, time complexity means no loop. Just write plus C. If no loop, just write plus C. If loop is there, one time, plus N. If loop is there, inner loop, two times, N square. If loop is there, three times, inner loop, N cube. So go wherever you want to go. If no loop, write plus C. If you don't write anything, meaning is no time, no question of no time. The first program you written hello world, that will also take constant time. Every program will take minimum constant. You cannot say this program cannot take any time. You cannot say this program cannot take any time. Yeah, so Shobit saying that missing your buffalo word. Are Shobit, you and your friends are buffaloes. Shobit, you and your friends are buffaloes. You are the main buffalo in that particular area. In your friends group, you are the main buffalo. Right, perfect. So can we go to next? Yeah, I think recurrence relation for time complexity also written. Let's go for next one. Listen, let's go for next one. Recurrence relation for additions. Recurrence relation for additions. Additions. Right? Let me try. Let me write. See this one. A of n is equal to recurrence relation for addition. A of n is equal to. Can you help me now? Can you help me? If part, any plus operator, no, 0. If n is equal to 0 or n is equal to 1. Yeah, if part, no. Can you go to else part? Else part recursion there, as it is right first. Recursion you write as it is. Recursion you write as it is. Plus, in the recursion, one addition there. In the else part, if you observe, one addition there. In the else part, if you observe, one addition there. So what is the answer? Plus 1. If n greater than 1. Right. Umesh written for everything correct. Umesh written for everything correct. Umesh written for everything correct. Umesh, you are correct. Arey Praswal, how are you? Arey Praswal, how are you? Yeah, now see the next one. See the next one now. Multiplication also, I think it's a multiplication or addition. Now see the multiplications also. See this one, recurrence relation for multiplications. Recurrence relation for multiplication. See the answer. M of n is equal to see this one, M of n is equal to, see the answer. If you observe clearly, in the if part, no multiplication, so 0. If n is equal to 0 or n is equal to 1, 0 multiplication. If you come to the else part, nowhere multiplication. It's going to be m of n minus 1 plus m of n minus 2, right? Because of no multiplication plus 0 means nothing. If n is greater than 1. So this is the recurrence relation. This is the recurrence relation. Yeah. So now can you check now? Those people who are having small doubt also, let me know. 2 problems we done. If you are okay, these 2, you done the great work today. If you are okay, these 2 problems I done. For every problem I done 4 models. 2 problem, right? 8, right? 4 models I done. I think 2, 4, totally 8 I done. Anyone having any doubt, let me know. Anyone having any doubt, let me know. Anyone having any doubt, let me know. If no doubt, write no doubt. If no doubt, write no doubt. If no doubt, write no doubt. Right. So because of all people are okay, all people okay. Now see this one. Before going to the next problem, can you see this? Let me say something about Unacademy. Before going to the next problem, right? Let me say something about Unacademy. So if you are preparing for 2024, if you are preparing for 2024 GATE exam, right? 2024 or 25, whatever it is. Or you are studying second year BTech or third year BTech or fourth year BTech, right? Or I can say you are preparing for jobs, or maybe you are doing job, right? So my suggestion is, if you want to prepare for GATE exam, examination, please start preparation now. Start preparation now. Join Unacademy. My suggestion is join Unacademy. It is really helpful to you. Join Unacademy. Right? And one more thing is, use referral code ReddySir. Use referral code ReddySir because 30% offer is going on. 30% offer is going on. Use referral code ReddySir. 30% offer is going on. Utilize it. Utilize this. And one more thing is, see this one. One more thing is, all India, right? All India, right? Practice test is going on. All India practice test is going on. 4th December, 18th December, January 8, 15, 22, 29. All India level, right? Practice test going to be happen. 4th December, 18th December, January 8th, 15th, 22, 29. Don't miss it. Use referral code ReddySir, right, to get, right, to write this test freely. If you want to write this test freely, use referral code ReddySir. Next one, zero cost, right? 0% interest EMI. Means you can go for EMI option also. 0% interest. Within 2 hours they will approve. Minimal paperwork. Flexible tenures. Next one. Ignite batch is started. Ignite batch is started on November 24. Ignite batch started November 24. November 24 means I think yesterday. One class is over. One introduction class is over. My suggestion is, see this one. Algorithm I started. In the Ignite batch, right? In the Ignite batch, algorithm I started. Morning 6 a.m. Algorithm started. Algorithm total classes are 50. Right? In YouTube I can teach maximum 15 classes. Algorithm actual number of classes are 50. I taught only maximum 15 classes. Right? In my opinion, tomorrow most probably last class of Algo. Tomorrow or day after tomorrow is the last class of Algo. My suggestion is, if you are really interested to learn Algo data structures, or you are seriously preparing for a GATE examination, please go for Plus or Iconic. You can go. Algorithm started yesterday only. One introduction class happened. 6 a.m. morning. So after Algo is over, I will start data structure. I will start programming. Next one, TOC, compiler design, computer network, discrete mathematics, digital. Right? These are the subject. Algorithm, data structure, programming, TOC, compiler design, computer network, right? Discrete mathematics, digital. These are the subjects which I will cover. Right? Remaining subjects, so many good teachers are there, you can follow them. My sincere suggestion is, if you are serious about 2024 GATE examination, don't miss it. Join today. 30% offer is going on. Use the referral code ReddySir. Next one, if you go for Iconic, you will get so many advantages. My suggestion is, go for 1.5 years. Iconic you can go, because if you go for Iconic, you will get all advantages. If you go for iconic, you will get all these advantages. 2024 is your target, right? Start today. If your goal is 2024, please start now, right? When our exam is 3 more months, don't join that time. Don't torture yourself, don't torture your family, don't torture me also. Get exam is there 6 more months or 3 more months. Joining that time, right? Getting pain by yourself, family also, me also. It's not at all advisable. 2024, plan today. Take the subscription in Unacademy, right? Try to do every day your level best. Automatically rank will come. If you start now for 2024, right? Until June, complete the syllabus. Right? August, right? June, July, August, September, go for revision and all. Right? July, August, September, go for revision. October, November, December, January, practice. If you can follow this procedure, right? Again, I'm repeating now. If you join an academy now, if you start the preparation for 2024, right? June ending complete syllabus. July, August, September revision. October, November, December, January practice. Right? If you can do this, even God also cannot stop. Even God also cannot stop your rank. When you have nice planning, no one will stop. If you don't have any plan, right? Everyone will stop you. If you don't have any plan, everyone will stop you. Remember, you are ordinary student. With the great plan, you can do extraordinary things. Ordinary students also can do extraordinary things with great planning. Right? Even though you are so talented, if no planning, you cannot do anything. Even though you are so talented, if you don't have plan, you cannot do anything. With plan, you can beat anyone. Without plan, you cannot beat even ant also. If you don't have plan, even you cannot do anything. You cannot do anything for ant also. My suggestion, let's have plan. Right? Think that you are targeting 2024. That is your target. 2024 is your target. Assume. Plan now. Join now. Right? Join now. So this is my suggestion. I given the plan also. All the people who got the very good rank, the reason why they got very good rank is not because of extraordinary and all. They have plan. All great people are having plan. Right? If you don't have plan, you will become a normal. If you see labor, those people who are doing the labor work, watchman, peon, right? All the small works, whatever they are doing, they used to do lot of work. Still they are not able to get whatever they really want because no planning is there. Blindly doing. If you do blindly, right? If you do blindly, it's something like labor work. If you do with plan, correct time, right? It's going to be some extraordinary thing. So my suggestion is please start now, crack 2024 GATE exam. Any doubts, let me know. Raj is saying that if you used your code ReddySir, then 30% is off. Yeah, I think so. Mr. Ross, I think so. Can you try once? Can you try once? You can use that, I think so.
Yeah. So Raj is saying, sir, yes sir, it is working. Raj, take subscription 100 times. It will work more better. Raj, take the subscription 100 times. It will work more better. 30% will come. Right. So today some nice thing happened. Today's class. Listen. Today's class and yesterday's class. Can you see? If anyone can see today's class and yesterday's class, you will get the recursion clearly. Today's class and yesterday's class, if you see, I am repeating once again. Yesterday's class, today's class combinedly, if you see, you will get the recursion clearly. And one more. Before that, 3 classes, if you see continuously, you will get time complexity clearly. 3 classes I took for time complexity. 2 classes I took for recursion. 2 classes I took for recursion. Please see both of them. 3 classes for time complexity. See both of them. I hope you will utilize this class. My suggestion to everyone of 2024, target now. Target now, I am saying to you. Target now. If you are belongs to non-CSE, I'm really saying, if you want to join the CSE, you are most welcome. You are non-CSE person, you want to write CSE GATE exam, you are most welcome. I see many people. I will guide you in the nice way. So many people I guided, even though you are non-CSE, you can happily write CSE GATE exam, you can crack very good rank. My suggestion is plan today for 2024. Some people are there, they are planning 2023 now. 2023 GATE exam they are planning now. It is not possible. To be frank, it is not possible. Better planning is 2024 plan now. Don't plan 2023 now. If you are preparing from last 6 months, then it's a nice idea. 2024 plan now. Right. See you tomorrow. Right. Good night. Take care. Bye bye.